Hello, welcome to our next lecture on IP addressing. So, to access anybody, we need some information. To send a letter to somebody, we need the address of a person. Same way, to communicate with a machine, we need to know the address. So, before we go and discuss what an IP address is, let's understand some basic terms. So, there are three terms which are interchangeably used, sometimes misnomer, but there are three different terms. First is called naming. Naming basically says what it is. It identifies who you are. So when you say my name is Ram, it basically identifies I am Ram. It doesn't tell me anything about where my address is, where do I live, how somebody can reach me or something. Second term what we use is what is called addressing. Address is where something is found, something stays. So when I say my address is CS department KSIT, that tells me where somebody can reach me. I could be anywhere, but if a letter is sent at that address, I'll finally reach it. So basically it tells me where do you locate, where do you find somebody, that's an address. Just because you have the address does not mean you can reach it. Let's say you live in Jayanagar and you want to come and meet me at KSIT. You need to know how to come, which route to take, which crossings to cross, what is the path, what is the route. You need to take a Google map and figure it out. So primarily we have three things called naming, addressing, and routing. Naming tells what it is, what the entity is. Address tells you where it is, and routing tells you how to reach it. So let's look at the example. So we say Case Institute Technology. Sorry, there is a typo error there. This should be technology. Let me just correct it. Just give me a minute. So name is K Institute of Technology. Address is Raghuvandhalli, Kanakpura Road. And route will depend upon from where you're coming. If you're coming from south of Bangalore, Kanakpura, route could be different. But if you're coming from Jayanagar, it could be different. So when name and address does not change, route would change depending upon from where you are coming. This is what basically same thing is needed for our machine. To reach a machine to send a packet, we need to know the address. And in internet word, it is called IP address. With IP addressing, there are a number of terms associated. We'll probably look at. There's a good paper by Chaksamaria from 3Com. Now 3Com company is no more there today, but the paper existing, you can find it out. And we probably, those are a number of terms, and they're all used in IP addressing, but we'll basically look at the what subnetting is. That's what we're going to study. We'll also look at what a host number is. We also look at what a network prefix or network number is. And then sometime we also look at longest prefix match. Today class A, what we call class A, class B, class B, class A, class C. This classes has gone away, and today we for IP what follows called classless routing, classless addressing, which is also called CIDR, classless inter-domain routing. So we'll look at those, and that's where the network prefix, prefix length, subnetting, all that will come to the picture. Let's look at the address. Let's look at the website, my own website, rprustagi.com. What is the address? How do you find the address? One address is website name. From machine perspective, it's IP address. You can probably find by using a lookup or doing a ping. So my website name is www.rpuristiki.com, or you can say rpuristiki.com. Its IP address is 69.161.146.196. We'll get into the details of how what is the format, how do we write it, how do you convert it. We'll get into all those details. And to route, how to reach this site. So depending on if you are sending a packet from your home, it will follow different path. If I'm sending from my home, follow different path. So you can use a command what is called trace route on Linux, and on Windows it is called trace rt. You can use this command to find all the routers in between from your host where you're trying to access to the destination. So below gives you the number of routers from my home to my site. So first address is 192.168.1.1. Second, it goes via Airtel broadband because I am connected via Airtel. Next also happens to be Airtel broadband, and so on and so forth. And then you can see probably there will be 17, 18, 20 routers between me and my home. So what really is an IP address? How long it is? How do we write it? So when the internet was designed, it was thought there will be not more than 2 raised to the power 32, or what is called 4 billion computers in the world. So it's a 32 bits are good enough. So IP address were assigned 4 octets. Please know the difference between octet and a byte. We happen to choose we happen to use we happen to use sorry we happen to use the octets and bytes in the same way. Octet precisely means 8 bits, even though today byte also means 8 bits, but there are some systems where byte had a 9 bits, something else. So if you want to be technically correct, I would recommend you to use the word octet and not bytes, but both are interchangeably used today. So if you look at, in this case, a simple picture, you can write in decimal form, you can write in binary. We know that we say IP address is 32 bits, so we can write in 32 bits, and this is how the IP address is. So each machine, whosoever has got the 32 bits, so machine A, PC1, this is the IP address, PC2 has this IP address, the routers in between, router has one IP address, another IP address, and so on, so forth. I will get into those details, how the address mean, how to get binary. So typically you write IP address either in binary form or in a form called decimal dotted notation, which is a.b.c.d/n, which basically means we have 32 bits. So divide into 4 octets of 8 bits each, and for each 8-bit octet, write the number in the respective decimal and separate them by a dot. Dot, dot. So when you separate them by a dot, so 3 dots, this is also called DDN, or decimal dotted notation. So you take the 32 bits, divide into 4 octets each of 8 bits, write them in decimal form, and that becomes decimal dotted notation. And sooner in the next lecture, we'll cover in more detail what is this slash n mean. It's subnet mask. We'll get into detail in our next lecture. So look at this diagram. In this diagram, if you look at, we have a PC1 whose address is 192.168.10.10. There's a PC2 whose address is 192.168.11.10. And these two, PC1 and PC2, are connected by a router, and router has two interfaces, gigabit 0/1, gigabit 0/0, and the interface address is given 192.168.10.10 and 192.168.11.1. And this router is connected to internet, and let's say this could be some server which you want to reach. So PC will send a packet to this router, it will send a packet intermediate router, and finally it will reach. And that we'll study in our subsequent lectures when we discuss with routing. So primarily if we look at how does the address look like, address follow a hierarchical scheme. Let's say consider your house where you live in, and let's say one door opens on third main. So one door opens on third main, another door opens on let's say fourth cross, and third main, your house number happens to be 100, and fourth main, your house door number happens to be 200. So what your house address would be? Would you call it 100 third main, or will you call it 200 fourth cross? What would be your IP address? What would be your house address? Aren't both address valid? So actually if we look at, when we say the address number 100 third main or number 200 fourth main, you are actually giving an address of the door of the house and not really the house address. If most of the houses have only one door, so we can synonymously use house address same as door address. But if a house has multiple doors, each door would have a different address, and that's how it would be. Same way in the machine, in the IP address is a 32-bit identifier, and this 32 address is always assigned to an interface of the machine. So if a machine has two interfaces, it will have two IP addresses. If a machine has four interfaces, it will have four IP addresses. And if you look at today, most of the time you look at your phone, it has you connected on Wi-Fi, you connect on 3G network, two different interfaces, typically two IP addresses. You take your laptop, you connect on Ethernet, you connect on Wi-Fi, you connect on Bluetooth. So it has probably, depending on which interface you connect to, each interface would have its own different IP address. Two networks are connected by a router, so we'll come to what a network means. And this router would have multiple interfaces, and each interface would have its unique IP address. Like we said, in the case of your laptop, it has two interfaces. One is your wired Ethernet, other is wireless or Wi-Fi, and that means it will have two different IP addresses. We'll also look at, when you look at the machine details, will come in a short while. It also have what we call is loopback address. It's typically called LO, and its address is always 127.0.0.1. This address is typically created with the purpose that even if your laptop or machine is not connected to any network and you want to develop a simple network-based application, want to test it out, you can run your own client on the same machine, you can run a server on the same machine, and using this address you can test entire application. And if the application works with this address, it will work on the other as long as routing is fine. So please note again, as I said, IP address belongs to the interface and not to the machine. You can use interchangeably only because if a machine has only one interface, we say what is your machine address. So technically, when I ask a question, what is IP address of your machine, which is a wrong question, but we'll assume that your machine has only one interface connected, so we can use the two as the address of a machine or address of interface of a machine in interchangeable. Let's look at the example of different networks. So I have one network, this is network 1, another network, network 2. We'll get into details of how to define these. So this is network 1, network 2, this is my network 3. So let's look at network 1 has one machine 223.1.1.1. It has second machine 223.1.1.2, third machine 223.1.1.3. Same way network 2 has a machine 223.1.2.1. It has another machine 223.1.2.2. Same way, let's look at network 3. Network 3 has one machine is 223.1.3.1 and 223.1.3.2. Since these are three different networks, network 1 consists of all these laptops, network 2 consists of all these machines, and network 3 consists of all these machines. If they need to talk to each other, we need a router in between, and we basically get a router. And now router has three interfaces: interface 1, interface 2, one minute, interface 1, interface 2, and interface 3. And that way you can send. So if you look at, and I want to look at how to look binary. So look at the router interface 223.1.3.27. You write it in binary, 223 in binary, then 1 in binary, 3 in binary, and 27 in binary. So 223 in binary would be this: 110111111. 1 in binary would be 00000001. 3 in binary would be 00000011, and 27 would be 0001 and 0001 and 1011. So that way, let's do some more exercises to understand how to convert an IP address into binary. And then, and when you look at the network, when you identify, how do we decide that the given the three machines belong to same network, different network? That is where binary operations would be needed. We need binary bits, and hence we need to understand how to convert a given IP address into a binary format, and vice versa. So consider, let's say, an IP address 192.168.10.11. How do we write into binary? So we take first octet, which is 192, convert them into binary. So look at 192 will be corresponding to 128 plus 64. This makes it 192. We don't need other bits. So essentially the 192 will correspond to 11000, and thus the address would be written as 11000000. Now let's repeat the process. Look at the second byte or second octet, second value 168. So please pause the video and work out your decimals. Look at which of these things corresponds to 168. When work it out, verify your answers. Assume you worked out, you look at 168 corresponds to 128 plus 32 plus 8. That means this bit, and this bit would be set, and rest all would be 0. And thus, if I were to look at, this would be 10101000. And so if I need to write same thing in binary, first is this is 192 and this is 168. Now repeat the process. Please take the third octet, and can you convert the 10 into binary format? Pause the video. Once you are done, you can resume back. So if you look at this, assuming you are done, look at 10 corresponds to basically 8 plus 2. That means this bit would be set and rest would be all 0. So this answer would be, until third, our binary representation would be this. Please pause the video and convert the binary of 11. Assuming you have done, verify that. Look, 11 corresponds to 8 plus 4, 8 plus 2 plus 1, that is 1, 1, 1. This is what you get. So this is how you convert a IP address into binary format. Now we said that the IP address is hierarchical. Like our house, it can belong to street 3, or I can say it belong to uh, Raghuvanalli, or it can say belong to South Bangalore, or we can say it belongs to Bangalore, then we can say belong to Karnataka or India. So depending on which context we're talking about, we will always talk in terms of locality, we build a hierarchy. Same way IP address is hierarchical, and that means it has two parts. One is called network number or network prefix, and other is called host number. Or that means given the 32-bit address, assuming this is your 32-bit address, you decide depending on the hierarchy, is your network here, or is your network up to this part, or is your network up to this part. So whatever the first part is, you divide. This is called network part, and whatever remaining part is, this is called host part. So remember we said our IP address format is A dot B dot C dot D slash N. This N corresponds to number of bits in the network part. So if we say slash N is 20, that means we have 20 bits on the network part. If we say slash 23, that means first 23 bits are the network part, and so on, so forth. So you set the two parts and we divide, and this is what we'll use. So you look at all the machines when you say how do we decide that different machines belong to same network. For all the machines belong to same network, their network number would be the same. Let's say if a network mask is slash 20 bits, that means first 20 bits of all the machines in the network would have same value. When we say machine A has a different network than machine B, then its first 20 bits, there will be at least 1 bit difference from address A and address B. And that's how we determine whether machine belong to same network or a different network. For different machines belonging to same network, their first n bits would have the same value. Their host number would be varying because two machines have different addresses, the different value. So the two machines would basically differ only in the host number part, but they would have the same value in the network part, and whatever is less n is number of bits, that number of bits would have the same value. And this is how we use subnet mask to decide how it is. Initially, when it started, designer thought there'll be three category of networks. One is a large network, one is a medium-sized network, and one is a small network. Please remember things has evolved, and probably you may remember that a lot of type predictions that has gone wrong. Probably you know famous a code by Thomas Watson, founder of IBM. Probably world there 5 computers are good enough for this world, and we know how many computers are today. There is a famous code which is attributed to Bill Gates. I'm not saying whether right or wrong, but as attribution is Bill Gates has once said, why does somebody need more than 640 kilobytes of memory in a system? But without bothering about the skits or not, but there things are. So initially we thought 38 bits are good enough. In the same way initially designed, there were large networks, large corporations, medium size or small networks, and hence they decided three categories called Class A, Class B, and Class C. In Class A, network numbers were only 8 bits assigned. For Class B, 16 bits were assigned for the network number, and Class C, 24 bits were assigned. So that means for Class A, I have 8 bits. That means for the host part, I have 24 bits. So that for the Class A, I have 8 bits, and for the host part, I have 24 bits. For the Class B, we have 16 bits assigned, and for the host part, we have again 16 bits because remember, total number of bits are 32. And for Class C, we are assigned 24 bits for the network, and we have 8 bits for the host part. That means there can be maximum, if a address belongs to class C, only 8 bits are given for the host part. That means there can be only 2 raised to power 8 is 2 raised to 56 addresses in that network. For class B, same way, number of addresses can be 2 raised to power 16, which is 65536 addresses. And for class A, total number of machines in a network 2 raised to power 24, which is 16. But please note, since there are only slash 8, that means total number of class A network can be 128, which is too small a number, or class B has only 65,000 networks and so. Now this class concept, what we're seeing today, has basically become outdated now, because now let's say somebody has 1,000 machines. Does it need to use class B? Because class B would have 64K addresses, but I'm only 1,000. So if I have given class B, I'll be wasting 64,000 addresses. It's not worthwhile, and hence the concept of classes is not being used today. And what we use is called dynamically adjusted, depending on, based on the number of machines you need, that many bits will be assigned to you and you use those. We already discussed that you take the IP address, take the values of 8 bits, write them in decimal form, separate them by a dot. So this value becomes 145.10.34.3. This is 145, 10, 34, and 3. And all these decimal value, when you write in with separated with the dots, that's why it's called DDN, dotted decimal notation, as also what you call DDN. And for class A, now the classes are not being used, so let's not even worry about it. We'll get into those details when you look at your IP address assignment. Subnetting will do that. That's all we have to say, but just to understand that you understand this thing, do some exercises. So first I would say is take your desktop or laptop, whatever you got, connect to your home internet or college internet Wi-Fi, identify IP addresses of your interface. So you can probably look at the system configuration, identify what is the loopback address. This should always be 127.0.0.1, and look at the Wi-Fi interface IP address. You'll probably know. If you are using, let's say, Linux machine on terminal, you can issue the command ifconfig -a. It will give you list out all the interfaces, and whichever interface has got the IP address, it will give you the IP address. This is for Linux. If you are using Windows, you can probably give the address, the IP config is not IP, and then get the addresses, or you can look at network tool and find the addresses. Second exercise, just to know that how this works, take your smartphone, connect to internet, again find the IP address of your Wi-Fi interface of the phone. Or what you can do is your home laptop and Wi-Fi cannot your laptop and your smartphone connect to the same internet at your house or office, and see how are the two addresses different. Make a note. To look at the phone IP address, you can go to about screen, look at the settings, and you probably look at the address. Third exercise is connect your smartphone into a Wi-Fi hotspot, connect your laptop to the Wi-Fi hotspot, and then again find the IP address of your laptop. Second exercise is, as a user, you are using internet, list out the 5 most using website which you use on daily basis. For example, google.com or Facebook or Instagram or Twitter or LinkedIn or whatever website you use, find their IP addresses. To find the IP addresses, either you can search Google again and say give the IP address this, or on your own machine you can issue a command. You can issue a ping command on terminal window of a machine. If it is Linux machine, you can say ping -c2. C2 means send only 2 packet, and it will give an output reachable, it will give IP address. For example, my own site, if you ping get 2 packet display the IP address. Same way you can do ping google.com or facebook.com. And if you're using Windows, C is not the option, use -n, which is for Windows and 2 packets. If in Windows, if you don't specify parameters, send 4 packet by default. But in Linux, if you don't specify, it will keep sending it till you abort it. On Linux, to abort, use Control C. So this way, identify the IP addresses of all the 5 websites that you use on daily basis. To know the routing, you can use the trace route command. Issue a trace route command that we see in the first exercises and see what are the addresses, what are the routers that come between your machine and the respective site like google.com or facebook.com, and note down the addresses and see how many routers a packet has to go through before actually goes from laptop. That will give you the idea. Trace route also gives you the delays, how long it takes from machine to each router in the path, and you can determine which is the bottleneck link between you and the Facebook or you or the Google or whatever website you are using. Just to summarize, we basically discuss IP address, which we said is 32-bit or 8-bit octet. So sorry, it is wrong, not 8 octets, it is 4 octets. Let me just correct it. And 32 bits address or 4 vectors each of 8 bits, and we use what we call is decimal dotted notation, and this is what it is. So next lecture we'll look at subnetting, how to find whether 2 machines belong to same address, and figuring it out what the different network, same network, how many addresses. We'll discuss all those in the next